In question 2 we have a diagram showing a snowboarder on a slope. In A we're told they travel 1.5 meters from B to C in 0.43 seconds, with the velocity down the slope at C being 5.0 meters per second. Where to find the velocity at B? Well, for this we can use the distance s is equal to u plus v over 2 times the time t. Rearranging for u, the initial velocity, we can then put in the values given, and this comes out at 2.0 meters per second. In B, the combined mass of the snowboarder and snowboard is 75 kilograms, and the angle of the slope 25 degrees. In part 1 we're to find the component of the weight of the snowboarder and snowboard acting down the slope. Well, the force will be given by the mass times the gravitational field strength times the sine of angle theta, in this case the 25 degrees. Putting in the values, we get a force down the slope of 310 newtons. In part 2, we're told at point D the snowboarder has reached a constant velocity, moving 2.0 meters at a constant velocity between D and E. Where to find the work done against the resistive forces as she moves from D to E? Well, at a constant velocity the resistive forces must equal the force down the slope, which we've just found. And work done is force times distance, which is 310 newtons for 2 meters, 620 joules. In C, we're to state and explain what happens to the gravitational potential energy lost between D and E. Well, there is no increase in kinetic energy, so all the energy lost does work against the resistive forces due to friction with snow and air resistance. This energy is then lost to the surroundings as heat.